Welcome back to the Querying and Selecting Spatial Data module. In this portion, we are going to talk about spatial queries in ArcPy. The ArcPy tool that executes spatial queries is called Select Layer by Location. This tool is also found in the Data Management Toolbox as well as the Select Layer by Attribute tool that we learned about in the previous section. Here you can see the syntax for the tool and also the reminder that the in layer for this tool is the out layer from the Make Feature Management tool. So this is your reminder that this is a selection tool, meaning it only works on layers, not physical data. So you first have to run Make Feature Layer, and that the output from this tool is also an in-memory layer with that selection applied. And again, notice that you see the two different syntax methods for the tool. You'll see all of that. It has one required input here, and then you'll also see that it has several available optional requirements that you can do: the overlap type, the select features, which is going to be the data set to use in the selection, a search distance if you want to use it, a selection type, are you going to be doing a new selection, a select from a subset, etc. And then also if you would like to invert your selection. So that's kind of a reverse selection if you would like to do that particular operation. All right, so here is the syntax explanation for this tool. And again, I found this by going to the online documentation for the ArcPy tools in ArcPro on Esri.com. You can see here that for the one required input parameter, which is in layer, over here you'll very clearly see that the data type is a feature layer, meaning you can't put in a data set. It must be a feature layer, which is going to tell you that you have to first run the Make Feature Layer tool. All of the available options for the overlap type here, notice that there are almost 2 pages of them. Which one you choose is going to be completely dependent upon your analysis scenario and also the geometry of the data that you're working with for your in layer and your select layer. But you do want to take note of the data type for this particular parameter. So this is an optional parameter, overlap type. Just notice that the data type here is a string. It being a string means that you're going to put what's in the first part of this stuff here, which is in all capitalized letters, is going to be within quotes. So that is going to be an important part of your tool syntax. Looking further at the syntax explanation, you will see that the select features also must be a feature layer, but you'll also notice when we go into the scripting that we can actually use a data set on disk for this particular option. We can put in a feature layer and add that extra step, or as you'll see in our examples, we can also put in a GIS data set. Notice that the selection type is listed here as well, also an optional parameter. You can use any of these, but what I want to point out is that the new selection is the default. So for some optional parameters, there is something that gets run regardless of whether or not you put it into the tool. And these are going to be identified as default options. And you'll even see that down here that invert spatial relationship has a default setting, which is the not invert, meaning you don't want to invert your selection. So if you do not put anything in for these optional tools here, these optional parameters, then it will use what's identified as the default in the help documentation. So the selection type by default is a new selection. If you wanted to do something other than that, you need to make sure that you update your line of code to indicate that selection type. Okay, so here again, we see the syntax for the tool. And this tool again has a derived output, right? Because the input was a layer file, not a data set on disk. And the output is going to be a selected set of that layer file. Okay, so let's look at the code snippet here. So we'll see that the tool is selecting from the parcel layer those features that have their center in, so this is what they have chosen for the relationship, in the file geodatabase feature class called city limits. So here's where we get to see that the select features can also be an actual GIS data set, while the in layer must be an actual layer. So we are going to select from our layer called parcels layer those that have their center in the city limits. So that's taking advantage of that overlap type and the select features. Notice we don't have a selection type on here, but when we go back here, we notice that the selection option that gets chosen by default is new selection. So even though we don't put it into our code here, it is automatically assumed that we want a new selection. Okay, one more chance to look at this syntax and look through another example. So in this example, in this code snippet, this is demonstrating how we can put the derived output from this tool into a variable if we want to be able to use it further on in our code. So this is one way to work with these tools, which is to put their derived output into a variable. So in this particular example, we are using the select layer by location tool to select from an in layer called cities. So this is a layer file that intersect, and then our select features are this could be either a layer file, or this could be also a geodatabase feature class that lives in our workspace that's already been predefined. So we're going to choose the cities that intersect a feature that's called Chihuahua. Now, how do I know that it's either a geodatabase feature class or a feature layer? Because it does not have the .shp on the end. If it has a .shp on the end, it's indicating it's a shapefile. If it does not, that tells me that either it's a geodatabase feature class or it's going to be a layer file. And if you're the one writing the code and above this you've set up your workspace to clearly be a geodatabase feature, a file geodatabase, then this would probably be a geodatabase feature class within that geodatabase. So let's walk through each of these. So Chihuahua cities here, that is the variable that's going to store the derived output for cities, the selected set of cities. So it's going to be this layer with only those features selected that intersect Chihuahua. So the in layer is cities, the overlap type is intersect, and the select features is Chihuahua. So that's another example, the difference here being that we're putting the derived output into an actual variable. So let's walk through an example of our own. We're going to have a goal of selecting all facilities that fall within a county. So here is what that spatial selection would look like in a desktop GIS. You have a data set that represents a county, a data set where all of the points represent facilities, and we would want to select for all of our facility points that fall within our county, and that would be the spatial output that we would get, and the view we would get in a desktop GIS. So here's a look at the ArcPy code that accomplishes this task. So once again, the ArcPy module is imported and our overwrite option is set to true. The workspace is set to be where the data lives. We have also put in a little summary statement about what's going to happen. We have our tool syntax. So we know that since we're doing a selection tool, we need to create a feature layer. So we're going to have to use that make feature layer tool. And we also know we want to do a spatial selection, which requires select layer by location. So we have the syntax for each of these tools included in our code, which just makes it easier for us and any future users to script it out and making sure that we get all of the correct required parameters and those that are the optional parameters. First, we're going to create a layer from the GIS dataset. Notice in this example, I have put the facilities layer into, once again, a variable called facilities layer. Then we are going to use the select layer by location tool to select from the facilities layer those that are within the county shapefile, and we're going to manually indicate that this is a new selection. Now remember, this is the default selection method, so I could have, to get the exact same result, ended this line of code after county.shape. I didn't have to put on new selection because that's the default, but I wanted to show you how you get to that parameter if you want to include it and you want it to be something other than new selection. So notice here that when you're doing this, the search distance optional parameter comes before the selection option. So in order to get to the selection option, you have to bypass the search distance. And remember, we do that by just putting a placeholder of an open and closed quote. Finally, what's going to happen is we are going to report out to the user the number of features that are in our derived output from select layer by location. So we're going to print out the number of features that are currently sitting selected in our facilities layer. Okay, and here's what the output looks like. It tells us that the number of facilities within the county is 272. And then finally, like good GIS professionals, we're going to go ahead and delete that variable that is storing that in-memory version of our layer. Okay, so just like we thought about workflow with select by attributes, the same applies for select by location. So for a basic select by location in ArcPro, you would do the following. You would open the select by location tool. You would then identify the data set to select from and the data set to be used for the selection. And then you would decide on what the proper options and relationships would be if distance is involved and what your selection type would be. So you would essentially fill out this form. So in ArcPy, you're going to script essentially all of those options that you would fill out in the form. So a similar process, although first you need to make sure you create an in-memory feature layer using make feature layer management. Then you're going to run the select layer by location tool with the required parameters, paying special attention to both the overlap type and the select features. Now, before we go too far, I want you to remember back to your best practices of GIS data. So if we are ever doing a spatial analysis with more than one data set, we should never do that with data that's sitting in different coordinate systems or different projections or different spatial references. So coordinate system is equivalent to projection is equivalent to spatial reference. When you're doing spatial analysis, you, the GIS professional, need to make sure to move your data into a common coordinate system. The desktop GIS tools will allow you to put in data in various different coordinate systems into the tool and give you an output. But what you need to understand is that in the background, it is reprojecting all of your data to a common coordinate system because that's how it has to be in order for those spatial analyses to be done. Things have to be in the same common coordinate system in order to be able to have any spatial relationship with each other. So a best practice of a GIS professional is to have all of your data ready in the correct coordinate system to go into a spatial analysis. So we're going to make sure that we can then check for that in our code. So the best practice here is if you are writing a code that is going to do any type of spatial analysis where one or more or two or more data sets are going to be used together in a tool, you need to do a spatial reference check. And what this is going to do is it's going to revisit your knowledge of the describe function. Remember that creates the describe object. And one of the things that's on the describe object, that description of your data, is the spatial reference. The spatial reference property holds all of the different pieces of our spatial reference or our coordinate system or our projection. Those three should be thought of as the same thing. This spatial reference check is also going to introduce us to a new Python module called the sys module. This module includes some logic in it that allows your program to cleanly exit if something doesn't meet a certain condition. So basically we're going to set up our scripts to exit and give the user some information about what's going on if our data is not all properly in the same coordinate system. And finally, this all is going to revisit your if then else code logic as well. So let's look through the exact steps that you need to take in your code in order to do these projection checks. The first thing is you have to import the Python sys module. That usually happens at the very top of your code right after you import ArcPy. You then have to create a describe object for each of your data sets and capture the spatial reference property of the describe object in a variable. So for our example here, we're going to create a variable called DESC_FAC. So our describe for facilities is going to be equal to arcpy.describe, and then you put the data set in. So our facilities.shape. So that's creating the describe option where it has all of our properties now on our DESC_FAC. So from that, we are going to grab the spatial reference property. So we are going to say SR, which is just common convention _FAC for facility, is equal to our describe object variable, so that DESC_FAC dot spatial reference. So it's going to go and pull the spatial reference property from all of the things that are in the describe object. So this should look very familiar. We've done this in a previous module. You would do that again, same thing for our county data set. Create a describe object and then also pull the spatial reference. Then what that gives you the availability of doing is evaluating out the name of the spatial reference. So remember, one of the things that's on the spatial reference property is the spatial reference name. So we can then set up an if statement that asks if the the spatial reference name from one of those is equivalent to the spatial reference of the other, we're just going to give the user a message that says all of your data is a common coordinate system, spatial analysis can proceed. So that everything else would go straight down into the rest of your script. However, in our else statement, if that does not evaluate out to be equivalent, if there is something different, we want the user to know, and we actually need the script to stop so that the user can figure out how to get everything into a common coordinate system. So we're going to take advantage of the sys.exit method. And on the sys.exit method, you can put in a print statement into it to give the user some feedback. So for us right now, we're just going to say, please ensure that all data is in a common projection before doing any spatial analysis, ending the program. And when we do that, that's going to be a message to the user to go back and check on their data, and then they can come back and rerun the script. So then here is an updated version of our select by location script with the projection check now included. Here you can see what each line of code will look like in the grander scheme of things. And while it might make sense to build into a script lines of code to do the actual data projections, the project features tool, often the first run of a workflow of this type is best to just let the user know if they're dealing with data in multiple projections. And then if it's necessary, you can build in all of the necessary logic for determining what your coordinate systems are, what they need to move to, and whether or not you'll need any datum checks and if you'll need any geographic transformations. But I do want to highlight for you the lines of code that are doing this within the actual script itself. So you can see how things are justified at the left in the tabs for us. So you can see the two variables there are built for each of the describe objects for each of our data sets. Then we pull off of that describe object the spatial reference property, store that in a variable, and then set up an if-else statement, that logic statement asking us if those spatial reference names for each of these data sets is equivalent. If it's the same, then that we just go into what's in the if statement and the rest of your script can move on. And for this particular script, that means that you would move on to making the feature layer for your facilities, doing the select by location, and reporting out the number of features that were selected. However, if it evaluates out to be anything but equivalent, we enter into the sys.exit, which is taking advantage of our import of the sys module, and then we're just going to report out to the user that they need to go back and do something, the reason why the program is ending, and that sys.exit is a way for our program to cleanly quit at that point and not do anything beyond that particular line of code. All right, so now you're going to have the opportunity to do your own practice of your own select by location within ArcPy.